So in chapter 12, we're going to talk about arcs and chords. So by the end of this lesson, you should be able to apply the properties of arcs and the properties of chords. So there's three different types of arcs that you need to know about: a minor arc, a major arc, and a semicircle. A minor arc is an arc whose points are on or in the interior of a central angle, while a major arc are points that are on the exterior. So if you have this ABC here, this angle, the minor arc is in between those two, while the major arc goes outside. Now when we name these, we can't name them exactly the same way. So AC covers this distance right here, and that would be x degrees. But if you wanted to talk about the one around it, you need to give 3 letters so that you know I'm going in the opposite direction. So we have a random point out here, D. So A to D to C wraps all the way around. And since a circle is 360 degrees, you can just subtract however big this is here. The measure of a semicircle is always 180 degrees because it's half of a circle. So the circle graph shows the type of grass planted in the yards of one neighborhood. Find the measure of KLF. So we're going to start at K. We got to go to L and then wrap around to F. So we want to know this angle measure right here. Now it says that this is 65% of the types of grass. So what we have to do is find 65% of 360 degrees. So remember, 65% is just 0.65. So if you multiply 0.65 times 360, you end up with 243, or 234 degrees. So adjacent arcs, hopefully the word adjacent sends something off in your mind. Adjacent arcs of the same circle are ones that intersect at exactly one point. So R to S and S to T are adjacent or right next to each other. And we have an arc addition postulate that says if you want to find the measure of A to B to C, all you have to do is add AB and BC up if they're adjacent. So we can do problems like this. I want to find the measure of B to D. So B to D, this right here. We know it's not the other way around because they would have given us more letters to help us figure that out. So if I want to figure this out, I need to add these two pieces together, which we don't actually know. So stop and look at your circle. First thing I notice is that these are straight lines through here. So that means these two angles have to be the same because of vertical angles. And then the next thing I notice is that this is a semicircle if we go from B all the way to E. So that means everything here has to add up to 180 degrees. So 180 has to equal whatever this is, plus the 52, plus the 97.4 that we just found. And we can find how big that is by just doing some subtraction. 180 minus 52 minus 97.4, and we end up with 30.6. So that's how big this is right here. So then if we just want to find from B to D, all we have to do is add up 97.4 and 30.6. You end up with 128 degrees. The other way you could do this problem is you could notice that this was 180 and just subtract the 52 and you have all of that over there. Congruent arcs. Congruent means same measure, so congruent arcs are two arcs that have the same measure. So in this example, because they both have the same measure, they don't have to be kitty corner like they just were, as long as you know their degrees. So with congruent arcs, in a circle or congruent circles, if you have congruent central angles, so if these angles are the same size, then the chords are congruent. So D to E is congruent to BC. If you have congruent chords, if you know these things are congruent, then you know the arc measures from D to E and C to B are congruent. And if you have congruent chords, if you know that those two things are congruent, then you know the angle measures are congruent. So I'm going to tell you that T to V is equal to S to W. So that means that your chords are congruent. So congruent chords have congruent arcs, which means that BT is congruent to SW. So if I want to find SW, all I have to do is set these two things equal and solve for n. So if we move the 7n over here, add 11 to both sides, we get that n is 11. And then we can plug that in to find WS. So WS is 7 times 11 plus 11, which gives us 88. So then you can also get problems like this. PT bisects RPS. So we know this angle is congruent to this angle. We need to find RT. So if we go back to this, if we have congruent angles, then our arc lengths are congruent, and if those are congruent, then we have congruent chords. So that means that this has to be congruent to this. So we can set 6x equal to 20 minus 4x. And if we add 4x to both sides, we get 10x equals 20, so x has to be 2. And RT is just 6 times 2, or 12. Last theorems. So in a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. So that means if this is perpendicular, this guy is congruent to this guy, and this arc is congruent to this arc. And then it works the other way around. In a circle, the perpendicular bisector of a chord is its radius, or diameter, if you draw it all the way across. So if you know these two things are congruent, then this has to be your radius. So let's find NP. We need to find this distance right here. So the first thing that I'm looking at is the fact that this is perpendicular. This is my radius right here, 8 plus 9 or 17. So that means anywhere here, this is 17. So what we can do is we can draw ourselves another radius right here that we know is 17, and I can find this distance here. And once I know that this needs to be congruent to this, so I can just double it. So in my nice little right triangle that we have right there, I have a leg of 8 and a hypotenuse of 17. So 8 squared plus x squared equals 17 squared. This is 64 plus x squared equals 17 squared, which is 289. Subtract 64. We get x squared is 225, so x has to be 15. So because this is perpendicular, we know it cuts it in half, so NP has to be double that, or 30. So we'll do some more of this practice in class, but you should be able to apply the properties of arcs and chords to solve some problems like we just did. Make sure you write down any questions you have and we can go over them together. Enjoy your night.